Mu Arae, officially named Cervantes, is a main sequence G-type star approximately 50 light-years away from the Sun, in the constellation of Ara. The star has a planetary system with 4 known extrasolar planets, designated B, C, D and E, but now carry the Cervantean names of Quixote, Dulcinea, Rocinante and Sancho. 3 of them with masses comparable to that of Jupiter. Mu Arae C was the first hot Neptune discovered. Hi everyone, Vega here, and in today's video we return to our exoplanet series to take a look at one of the most fascinatingly similar systems to our Sun so far discovered. So let's get to it. First of all, the star Mu Arae itself is at a later stage in its life than our Sun. Its designation of G3 4-5 means that it's thought to be probably now slowly evolving away from the main sequence, and over the next 500 million to 1 billion years will reach out and develop into a red giant star, not too dissimilar from the star of Arcturus today. Cervantes is a slightly bigger and brighter star than the Sun, with a luminosity of 1.9 suns, meaning it has a slightly farther out and wider habitable zone. We find Cervantes in Ara, the Alta constellation, not too far south from the more famous stars of Lambda Scorpii or Shaula and Alpha Scorpii or Antares. So, what about those exoplanets then? The first one, Cervantes C, officially named as Dulcinea, after the neighbour of Don Quixote in the famous novels, was the first hot Neptune to be discovered. Orbiting at around 0.09 astronomical units, it's way too close into the star to be habitable, but unusual nonetheless. It's not fully known whether it is actually a rocky planet or a gas world, but as Cervantes has a higher metallicity than the Sun, it's possible that it is a rocky super-Earth, but unlikely. One can only begin to imagine the power of the wind and weather systems on a world like Neptune, but with the power of a Sun-like star just 13 million kilometers away. It's thought that the surface temperature would be about 900 Kelvin. From here on in, the planets get even more interesting. Cervantes D, officially named Rocinante after the horse of Don Quixote. This planet has a mass about half that of Jupiter, and orbits at a distance of 0.921 astronomical units from the star, with a period of 310 days, which as you can appreciate makes it an almost replica in terms of orbit as our Earth. Indeed, the planet may be located at a distance close enough to the star to receive a comparable amount of ultraviolet radiation as the Earth does from the Sun. However, we must bear in mind that as Cervantes is significantly more powerful than the Sun, Rocinante is likely too close to the star to be able to support liquid water at its surface. Furthermore, given its mass, the planet is likely a gas giant with no solid surface, but this of course does not rule out any moons of the planet. Whether a moon could be in the sweet size, smaller than Venus but larger than the Moon, enabling it to hold on to enough atmosphere to make it possible for water to form. Perhaps colonies around the polar areas or subpolar areas, or indeed in higher plateaus, could theoretically be possible on any of these moons. Or alternatively, the moons of Rocinante are just barren rocks, a bit like Mercury or our Moon. The debate on exactly why Venus isn't and Earth is habitable of course remains to this day. Planet Cervantes B, officially named as Quixote, is the third in the system and probably the most interesting of the grouping. The planet itself is at least 1.5 times the mass of Jupiter, and its orbital period, or year, is about 643 days, just a touch quicker than Mars' orbit around our Sun at 687 days. The orbital distance of 1.497 astronomical units from a star, given that Cervantes is more powerful than our Sun, does put it within the habitable zone of this planetary system. So again, as we often speak on this tiny channel, large moons of the planet, if they exist, could potentially support life. There are of course a few caveats to this though. Something that Quixote may not receive enough ultraviolet light for any abiogenesis to proceed, meaning life would not have started in the first place. Furthermore, it is not clear whether Earth-sized moons can actually be formed in the environment around a gas giant planet. Of course, in our own system, our largest moon, Ganymede, is more Mars-sized than Earth, and we do have evidence of a Mars-sized world in our solar system, in a Mars-like orbit. Unsurprisingly, that planet's Mars, and although sure it's not completely uninhabitable, and by solar system standards is positively a luxury hotel, it's still not exactly perfect, is it? Let's be honest. So barring something we haven't seen yet, we have to deduce that Quixote, more likely than not, does not have a habitable luscious Earth in orbit around it. But then again, we've never seen a planet like Quixote with its 1.5 Jovian masses, have we? So let's not just get too downhearted just yet. The final planet is planet E, also named Sancho, after the squire of the lead character of the novel Don Quixote. Sancho is another gas giant, this time at least 1.8 times as massive as Jupiter, and the planet orbits at a Jupiter-like distance of 5.23 astronomical units. Even though given Cervantes is a brighter, more luminous star than our Sun, assuming the lack of a greenhouse effect, any moon around Sancho would have a chilly, minus 138 degrees Celsius surface temperature on average, although it doesn't completely rule out unreasonably cold temperatures around the subsolar areas, or the areas in direct sunlight of the worlds. After all, we do know in our own solar system that those areas of Jupiter's moons of Kiilstofte, temperatures can reach double digits rather than triple digits below freezing. The star of Cervantes, known as Mu Arae, is a sun-like star that is beginning to turn into a red giant that lies some 50 light-years away. In orbit around it are 4 massive planets. The first, Dulcinea, is a superheated Neptune with terrifying winds. The second, Rocinante, is an almost Earth-like replica orbit, but is a gas giant with mass half that of Jupiter. It is thought unlikely, but not out of the question that moons around the world could harbour life. The third planet, Quixote, is a super-Jupiter in a Mars-like orbit, but given the higher luminosity of the star, it makes it lie squarely within its habitable zone. It is unknown whether any of its satellites could be Earth-size, or indeed harbour Earth-like conditions, but it remains highly possible. The final planet, Sancho, is a cool gas giant. While likely warmer than Jupiter, it remains outside of the habitable zone. In the novel Don Quixote, the lead character Quijana travels around Spain on horseback. One wonders whether one day in the distant future, travellers will likewise travel around Cervantes' fascinating and interesting planetary systems before it's too late. Thanks for watching and consider subscribing if you haven't already. If you would like to support the channel, you could consider joining the channel, which comes with some membership perks, or alternatively buy me coffee, and I'll link this in the description. Thanks to those of you who have already done so. If you have any videos or subjects that you'd like to see brought to light, don't forget to let me know in the comments below. Take really good care of yourselves and look after your friends and family well, and I'll see you on the next one.